So, let's see now if I can somehow take out the motor from this machine. Well, this motor looks like it's turning very freely, and I'm a little bit anxious and also lazy to take it apart. So I think I will just put some oil here and turn it around a little bit and leave it like that. Maybe also some oil here on the back side. I will see exactly where, and I will leave it like that. So I put oil on both sides, using this, and I put it exactly like in there, and I did the same thing on the back. I could just pull this fan a little bit out, and then I turn it around, and the oil went inside. That means that it was sucked inside. So I guess I would call this motor lubricated. I'm afraid to do anything more on this now. Well, after putting everything back together, I did the following. I have a tape here which has a recorded signal of 2000 Hz, and I know this. This is the headphone output, and here I have the program there that measures the frequency of the signal from these headphones, and this way I will check how accurate is the speed of the tape. So let's see. So what happened is that, as you can see, it starts at correct speed, but slowly it slows down. So this is still acceptable level, but now it went too low. This is more than 2-3%, and this is not acceptable level for speed deviation. You see, it started correctly from 2000 Hz, and as time goes by, it went to about 1900. So, the speed is not right, and it starts correctly and slows down as time passes. Normally, this kind of behavior happens when there is a problem with the motor capacitor. I have here a new motor capacitor for this one. It's 2 microfarads. It cost less than €2, so it's worth a try to see if this fixes the problem. I will now replace this, and we will see later what will be the results. So let me show a little bit what's going on here. The motor has 3 cables. It's a black and a white is the normal phase, and the other green, which is here, the other green is the other phase, which comes from this side here, from this side of the capacitor. So the normal phase goes to this side, and through the capacitor goes to the other side, and in the motor for the other phase. The reason that we have so many cables here is because this machine here has a switch to adjust, to adjust the capacitance of this capacitor according to which area you are, with power 50 or 60 Hertz. This capacitor is 1.5 plus half microfarads, so it's either 1.5 or 2 microfarads. When working on 50 Hertz, the capacitance has to be more because the motor takes more time. Because the other phase takes more time to reach the motor, so the motor needs a little bit more capacitance to keep, I don't know, I feel it, but I cannot really explain it. But generally the rule is less frequency on the power, more capacitance that you need. Okay, that's why I bought here a 2 microfarads capacitor. So I won't need the 1.5, which is for 60 Hertz power. So and this is a very simple capacitor which costs less than €2. Okay, that's it. I will now change it and see if it works. So as you can see here, I roughly soldered the new capacitor just to test and see if now it will work okay. And as you can see, the speed is very stable now. You see? It stays right on. Let's go to the other speeds. So half speed 1000 Hertz, and the low speed it's 500. It's well within range, so it's okay. High speed again, it's okay. So I consider this fixed according to speed. So after all the fixes I did, I will put the motor capacitor correctly, I will solder it correctly, and after all the fixes that I did, I think this is fixed. So I will close it and show the result. So, new capacitor installed. It holds strangely here, but I did test it, and it seems to hold okay. It doesn't move, so I will leave it like that.